I'm going to let everybody just say one sentence about themselves to provide background. And the goal of this panel is to explore knowledge graphs and large language models. And my plan was to ask all of the panelists for threats and opportunities. But my question, if there was more time for Jans, was knowledge graphs and large language models. Are they really made for each other? So
for me?
Well, why don't we go down the panel once and you say one sentence about yourself to give perspective of where you're going to come from, and then we'll give opportunities for threats and opportunities. And I want to open it to the audience as well. Okay, so Jamie's first.
Okay, so I'm Jamie McCusker. I've been actually working with neural nets longer than I've been working with knowledge graphs, but I think that large language models are complete and utter bullshit.
Go, Jamie.
Okay. Provocative is good.
You're next.
No, I've got my hand. Yeah. I'm very tired about all these conversations about whether this is real AI or not. I don't even care anymore, but I think it's an amazing language tool that you can use in God knows how many different ways. So.
And the one sentence about you?
Oh, well, Jans Aasman, CEO of Franz Inc. and working with knowledge graphs for 17 years now.
So I'm Helena Deus. I'm a data nerd. I'm a bioinformatics scientist, and I love anything that can take boring, repetitive work from human beings so that they can be creative. And so I love LLMs.
John Apathy. I've been spending 30 plus years in pharma, mostly in R&D, and just about everything I've learned about knowledge graphs and LLM have come from Lena.
I'm Tom Plasterer, AstraZeneca. So I'm a relative newcomer to large language models, but have been in the knowledge graph space for a number of years. And I think one of the things I'm trying to do is figure out how to translate this effectively into our organization. And I'm seeing more and more and more interesting examples. So now the question isn't, if, it's really a when, and how do we get people on board with this?
Eric Neumann. I am a card-carrying Drosophila geneticist originally, and it was about that same time that I started playing with neural nets. Not to do anything with the flies, except analyze their genetics and their output. But I've been interested in semantic graphs for a long time, and I kept pushing Tim Berners-Lee to start a healthcare life science working group, and we finally got that going. But my main, I would say, interest in keeping an eye on is where people are taking this computational frame with large language models, which I don't think any of us knew that if you throw in that much information and that much memory, it starts to put together very interesting kind of patterns. I even think you could take the notion of the hallucinations, and by putting a little bit of restraint on that, you can make it hypothesis generation. So that's something I would like to investigate more.
Cool. So we heard a few opportunities, and we heard one significant naysayer here. Well, so you were the odd person out on the initial statement. So let's be controversial.
Okay, so I do want to say that I'm not entirely negative on large language models or generative AI as a whole. I'm actually using it for some very interesting things. But the thing is that you have to very tightly control what you're doing with it, as Jans showed, that it's not like there's no magic there. You have to like really, you basically have to really kind of push the language model into a very specific activation space. And so one of the things that I see as an opportunity within large language models is is prompt engineering, but that's not the same thing as like the hype that's actually surrounding LLMs in the mainstream media. And so I think that we need to separate out the So there's the technical fact that, I mean, it is a bullshit engine, but it is also like producing a lot of hype around it that is also often unwarranted from kind of the media. It is a useful tool. It's an incredibly useful tool, though. I'm using it for things. But I do want to I do want to pitch out the idea that large language models are a smooth-brained organism. There's a continuous space within any embedding space, whether it's language models, graph models, any sort of backpropagation-based system currently, because they have basically a continuous activation curve. And so there's a bias that humans have when they think. And this bias goes back all the way to the first brains, not just the first vertebrate, basically the first vertebrate brains, possibly before that. It's probable that squids and octopi think the same way. And we think about things and the relationships between those things. Guess what that sounds like? But most neural system or most artificial neural networks don't have that bias. So I think that in order to get these systems to start thinking conceptually, to start thinking about them in ways that we might actually be able to trust, we need to make them lumpy, basically. We need to have these attractors within the activation space that correspond to things in reality that it's experiencing somehow. And so we do that without it's not like we have direct access to reality. We just have our perceptions. These systems have their perceptions too.
Okay, so that might lead into your statement of knowledge graphs and large language models made for each other. From some of the points that Jamie just made, do you really think they're made for each other? And give us some evidence and some particular fruitful directions for the general knowledge graph, both the people here as well as those listening later.
Well, to begin with, two statements. One, if I hear a person bullshitting right now, I just say, hey, you're ChatGPTing, right? Because this is a lot of people do that, right? It's just word after word after word. Doesn't make any sense, but they like to hear each other talk, right? So that's one thing. Second thing is, if Kingsley Idean said it way better than I do, but I would say if dumb people ask dumb questions, they get dumb answers, right? Kingsley Idean said if people with vacuous minds ask questions. Anyway, that's so you have to be really smart to get. You have to be smart, and you have to be a domain expert to be able to deal with a particular result, right? If you're not, you can be smart but not know anything about the domain, then it doesn't work. If you don't know and you only don't know the domain, but you don't know how to ask the questions, you also get nothing, right? So you kind of need a good balance between domain knowledge and knowing how to do the prompting. Then the other thing is, I've given you a bunch of examples, right? Of like 6 on the line. We have clinical trials. Clinical trials have inclusion and exclusion criteria, right? But there's no standard for it, so people just mix it up, right? Sometimes someone does first all the inclusion and then the exclusion. They just mix them. ChatGPT, you just give the inclusion criteria, and it said split between input and output. Inclusion, exclusion. Does a perfect job, better than a regular expression in the rules, right? You use it as a tool. It's a tool, knows about language, and I trust ChatGPT better than my regular expressions to get them to get out of it, right? So then I think the thing is, knowledge graphs are for structured information, right? So you can do aggregate queries, how many people this, how many people that, right? That's not in ChatGPT, right? So basically you extract structured knowledge from GPT, put it in a knowledge graph, and that allows you to do higher level queries, right? About things, to find correlations yourself doing your own statistics or whatever. Right? So basically I use ChatGPT to take or GPT, sorry, GPT to get to take unstructured information, whether or not I ask without giving it web search. That's, by the way, another really important thing, right? You can ask ChatGPT without the web search, right? You can answer what it learned. But it's also really good, as I said before, right? You do your query, you get 10 results back. You said, please read it and then answer the question, right? And again, it will give you a summary and structured info. You can even ask for structured information. Now, a human being could do it, would spend 20 minutes reading, right? ChatGPT does it in 5 seconds, right? And I get data back. And even then I can, for each sub-result, again, ask if there's proof on the web for this particular thing that I just discovered. So it's, yeah, but it's the mix of structured and unstructured. Plus it's a very smart human being to put it all together, right? So are they made for each other? The article that I'm writing, right, is literally about LLM and the knowledge graph and the human being have to work together to get a really good result. Does it make sense?
Cool. Yeah. Yes. All right. You wanted
a counter argument. Okay, good.
So GPT, as with most larger language models, they have basically two ingredients. It's the transformer model, which takes 3 character embeddings and positional encoding. But there's a second piece, right, which is what made GPT so attractive, which is the reinforcement learning with human feedback. And so in my mind, that knowledge GPT has is only as good as the people, the humans, who are giving it the feedback. And so they were general purpose people. OpenAI didn't go hire scientists and doctors and nurses to do the reinforcement learning. And so the way my PhD advisor taught me about, what a PhD is, he described knowledge as this sphere of, everything that humans have ever accumulated, right? And the PhD is like you're pushing against that sphere a little bit, right? It's like you're a little dot, pushing against the boundary of knowledge. And GPT knowledge, we could claim it's very right in many things, for sure, right? But it really can't tell when you're getting to a part of knowledge that's really at the boundary. And so it doesn't know when it's crossed the boundary. Whereas a human being, a scientist empowered by a knowledge graph, which initially it's in our heads, right? We put a knowledge graph in a computer when we're ready for it. But a human being can tell when they're pushing the boundary versus kind of being way outside of that boundary. So I think in fields that are still being discovered, still being understood, there is a very strong danger that GPT is going in and out of that boundary of knowledge without, the human on the other side having any notion of what's right and what's wrong from its answers.
Yeah, I think for the wine knowledge graph, I didn't care if there was a wrong tasting note, right? But for medical, it's probably a little bit more important that you get it right. But I think it's a win for
Humanity.
Well, no, not for humanity. I don't think so. But for the knowledge graph community.
I would push back against the idea that GPT knows anything. I don't think it doesn't know. It doesn't know. It doesn't work that way. It's not literal. Like the way we think about knowledge or knowing something, it has a set of words that it thinks are the best, thinks is generous too. It has, it puts one word in front of the other. And sometimes that can really look like knowledge. And it can do something that looks like information retrieval, but it's not, it's purely generative and not in any way that resembles something that looks like memory for humans.
I know, I don't want to take all the time, but one answer here is, so I'm a cognitive scientist, right? And I cringe every time when I see that word knowledge, right? Because a knowledge graph doesn't know anything, right? It's just a dumb graph database, right? But that a human being tried to structure in an intelligent way. But then you have GPT that will give you, like you just said, right? the next best thing it can find, right? By stringing words together, by the training that you just talked about. And then the third thing is a human being. For the wine database, you take one sip of wine and you know your wine, right? But because you're grounded in your senses, right? Except we can't talk about it, right? I cannot explain. I taste it, I know it. And now, because I'm not a wine expert, I don't know how to write it up, right? So you can say, I know it, but what use is that, right? Because so there's three types of knowing that you have in this case.
So sort of building off of both of your points, there was New York Times article not too long ago, editorial from Noam Chomsky and another contributor, talking about how it's really not language that we're talking about. And Noam Chomsky's been in this field obviously forever, one of the founders, and he was right. Of course, he was right, and it very much echoes Jamie's comments. But that doesn't mean that ChatGPT is not useful, as long as you have the guide that Jans wants. That's really smart human to help you. Get past the fact that we're just talking about statistical correlations.
Yeah.
So I really like the way that you frame that. So smart human, LLMs, knowledge graph. So I think that is the key. So.
And Jans and I aren't really, at least I'm not disagreeing with him about that. I think that that's like probably the best place to be, but I feel like the things that we want to do with it need a fundamentally different neural model under the covers.
Yeah, I second that. I think it also challenges us to try to, we think we know it, but it really forces us to try to define what knowing means, right? I don't think that's a real well-defined concept. It doesn't fit in a lot of places. In friend of a friend's, that's not knowing because it's symmetric, and I can know something the other person doesn't know back. But I think one thing that we get entranced by, I think the word entranced, which is also not formal, it has a flow. And I don't know if any of you've heard in psychology the concept of flows. Musicians and other artists like dancers, they know this. There's a part where the brain is sort of knowing what it's doing, but it's like an autopilot. It gets to see itself without having to worry about driving. And the flow that comes out of after a prompt, that sequence of notes is something that's irresistible to most people. It starts to like, why does that seem to resonate? And then you almost forget if the content is valid or not. But there's a flow in this. And that's intriguing. If it does flows, it doesn't have to be just verbal flows. It could be something that's more complex. For instance, you're talking about positional embedding. There are other types of embeddings. We could use the knowledge graphs of some areas that we know a lot as a structure, and it's ordered as an embedding to work, in transformer models. That's something I don't know how much effort that's going to take, but it's an interesting thing that it's not just about the position, which is usually a combination of sine and cosine waves. You could use structures for that. So I'm thinking there's a lot of other ways to make LLMs.
Cool. Well, John is the only person who hasn't commented yet. And one thing, if you want a prompt, one of your images was Einstein's quote of "In chaos comes opportunity," or "In great change comes opportunity." That might be something that you might be suited to comment on.
Yeah, I was just thinking about my contribution to this discussion. It probably comes down to a pragmatic, having lived through prior hype cycles. Where are we in this one, and how is it different this time around? And invariably, each one of those have prompted some form of a use case exploration or discovery process to find practical application. And I always find those, whether it was for big data or 2 years ago we did it for machine learning and AI, pre-LLMs, right? But they're all the same use cases. It's all the same business value and needs that need to get addressed. And so it's the same problems being rehashed with new technology. I think I wrote the phrase in silico modeling as a future technology that's going to impact pharma R&D in the year 2001. And here we are, it's arrived, right? And so your comment you made earlier about can we turn hallucinations into hypothesis generation? I think that's a wonderful question. I think of molecular invention and small molecule invention. We need more hypothesis to generate to explode the molecular space, and then find ways to rapidly test that. We had created an interesting construct where we were trying to marry the virtual world with the physical, meaning take all the predictive molecules invented against a target, and then store the predictive results, and then those that actually got made and tested, and use that as a kind of building up of a test set. I don't think anybody's really doing that particularly well. Probably AstraZeneca is. I say it, and I'm sure they are. But in the world of that's available to today, we could save all those results and then actually run them against what was predicted and build a better model. So I do think in this space, the things that are the application to push the boundaries of generative, I think, are the use cases that are the most interesting.
Go ahead.
Yeah, no, I would add to that we've got AlphaFold already, right? So there's like a problem that human scientists were taking decades to solve is now solved, right? We can get 3D structures from the sequence of amino acids. But you look at what's coming out of NVIDIA, right? We've got language models where the language is not English. The language is the language of DNA, the language of proteins, and so you can start to envision how, we don't understand. We kind of have some ideas of how DNA turns into molecules, and it turns into proteins, and proteins create cells, and cells create organs, and then we all get sick, and we don't know how the heck to translate, kind of like a mutation into a cure. These models, in my mind, are the way to get there, because we don't understand exactly the biology, and they can give us that approximation, right, between what happens to a DNA that gets mutated and the result that in a human being. In my mind, yes, even if it's a black box, how we get from a DNA that's mutated to a cure, and I think I'm fine with no explainability at this point if we get to cure people. So that's my argument for continuing to invest in large language models.
So started using the phrase perfect knowledge of human biology probably about 10 years ago. And, somebody asked me to estimate when would we have that. And I think at the time we said 2050 or some number like that. And perhaps with LLMs, maybe we'll have more perfect knowledge of human biology by which to then understand cures more rapidly, right? And so did we just jump the curve a bit? And that's an interesting question.
Just a slight build on that. I think we figured out a way to fill up the knowledge graph a lot faster.
Which will get us
there. But for me, that middle layer of having the knowledge graph well structured, that's always been the slowest part about what we do, but I don't mind that. So it really forces us to think about concepts. It forces us to think about relationships, and then using the LLMs and then using the generative AI to populate it. Okay, then we just make a new scaffolding. Because that's really going to help with belief. And so this is where I think we do want to go back to having the 2 or the 3 paired, as suggested.
So I wanted to push a little bit on I'm okay with no explainability. I'm not okay with no explainability. But I am okay with, this was in a podcast from Microsoft where they were pushing the co-pilot notion. And so you were using their tools to guide where you're going. And they use the phrase usefully wrong. And maybe that's another word for hallucination or fantasy or potential hypothesis. But no explainability is not okay from my perspective. But if I jumpstart, a hypothesis that we can explore, maybe that's okay. What do people think?
I'll just since I have this, I'll just jump in real quick. So no explainability is not going to pass muster with the FDA, for sure, right? So let's start with the obvious, right? So we need to have traceability. Even when Eric and I were doing biomarker research together 15 years ago, we had beautiful, beautiful patterns in mass spec around GCMS data that completely explained separation between different populations, those responded well to drugs and those that didn't. Beautiful biomarkers. All right, what is it? We have no idea. It's it's GCMS. It was shattered apart. We don't know what that fragment is, but it's reproducible. So I think we're going to see something really similar. So just because we think it's cool, it's just going to suggest the next experiment, next place to look. But that's not bad. That's not bad at all. And so I'm going to pass this back.
And we have a hard enough time when things are perfectly explainable, like mRNA vaccines, trying to get adoption. It's like, well, I don't understand it. Here, put it in your arm.
Do you know exactly what happens when you eat an apple? Right? Do you think about it? Do you just let your body do its thing? Right? I mean, at the end of the day, a lot of what we do on a daily basis, we can explain it, right? And so these AI systems, they are not human intelligence, not at all, right? They are intelligence, but their intelligence comes from these emerging properties. And we're trying to use the best names we have for them, like thinking or knowing. I mean, these are human terms. They're not LLM terms, right? But the reality is, even we can't explain everything we do, right? We're not aware of everything we do to kind of like get through life. And yes, we need to figure out a way to interact with these systems in a way that passes our, FDA criteria, right? And so, yes, the lumpy knowledge models make sense if we can ask GPT. But have you tried asking it to explain step by step how he came to that conclusion?
Oh, it's just more bullshit. That's what I'm saying. Is that, like, I'm not talking about like how you prompt it. I'm saying that at the foundation, like the neuron, how the ANN works.
Yes, and
wrong.
And part of the bullshit is because they're too large, right? The human brain only has 86 million connections, right? GPT-4 has 1 trillion connections, and the fact they're very large because they're doing very, very silly things. So there's groups of researchers who are actually looking at the weights that are being learned, and some of the experiments they tried. For example, there was one where they asked GPT, how do you, I'm in Rome. How do I see the Eiffel Tower? And he came up with like something like not in the GPT answer, right? That's kind of like parsed through policies and whatnot. But it's like when they analyze the weight, is doing something like, oh, move the Eiffel Tower to Rome, and then you can see it, right? It's like completely dumb, right? There's no mental model, but it has its own properties, emergent properties, right? So the question to me is not if we should or shouldn't use it to augment our own knowledge graph. It's like when and how.
So since I was a kid, I was stunned by people that could explain why they were doing things, right? Because I never could, and it took me a while before I understood that our behavior is way more controlled by our hormones, right? And by all the hormone systems that we have than actually by what we think why we do things, right? So our human behavior is highly unexplainable. I can tell you that. There's almost no decision where do we make, even if it's a job choice or whatever, we think that we make reasonable choices, but it's all driven by completely different systems, right? And not by logic, right? Logic is the last thing that you finally do as a rationalization why you made the choice, right? A judge, when he judges about a particular case, the level of sanctions, right, he's going to give, he knows I did research on this, within 10 seconds he knows what the sanction is going to be for this crime. And then he spends hours to write all the reasons why he thought that, right? Well, no, he was pattern recognition from the first second on. And now he had to justify against his colleagues and the lawyers, etc., why he made that choice, right? So when people talk about explainability, it's highly overrated, right? I mean, as long as you can predict behavior, right, or force behavior to occur in a certain way that you want, then you have an explainable system, right? Because you said,
right, but that's not science.
Huh? That's 100% science. You do it. You do an experimental variation.
You're right.
And
that's how you come up with a thesis, you know, what you want to do. Right. But then what you do is, now I got to build that experiment that tests not just my ideas, but all the counter ideas. And there's no other way out but that thing is proven. So you do it late, but
But
That's
you do
the
it.
end of the story then.
I was a psychologist working in a telecom lab, right?
Yeah.
So just how it works with all these incredible smart engineers. I said, it takes me usually 3 questions, maybe 4. And then they say, well, that I don't know, right?
Yeah.
So what is the level that you want for explainability, right? Down to the level of quantum or electrons or what do you call it? Currents.
Guessing at the beginning is
the
good.
whole point is,
Right.
right? It's just you choose your level of
Yeah.
where you accept your explainability level.
Well, yeah, and then there's a social, like, that's acceptable. You don't have to go deeper, but
Yeah.
And new things that are very different have a hard time cutting through that. I was going to ask, someone had mentioned earlier the Allen Institute. They had a TED talk.
Yep.
Did anyone see that one?
Yep,
No.
yep, I was
Okay.
there.
You were there.
I was
Okay.
there. Yejing Chao gave a talk
That's what I'm
on,
saying.
so it came out of the DARPA-funded Machine Common Sense program.
Right.
So she gave a talk basically, and it's up now. I haven't seen it, but she said it was up a couple
Yeah, it
days
is.
ago.
I just looked
Yeah.
it up.
Okay.
If you
So
haven't
she
seen
was,
it, see it. It's very good.
yeah, and actually there was a whole AI session. So Brockman, the CEO of OpenAI, opened the session. Gary Marcus was there, and Yejing was there, and her main premise was, we're not going to get acceptance of LLMs unless they get common sense. And by the way, common sense is like hard. But yeah, and the metrics that we're using to test common sense, you know, the language models were killing it before OpenAI. So this program is 3.5 years long, and the metrics that for testing in year 4 were being beaten by the machine learning models in year 1. But that just tells me that the metrics are not adequate.
Yeah.
But her big premise was we need common sense. But this metrics and testing angle is something that I wanted to make sure we spent a little bit of time on, because, you know, the world is really calling for guardrails and, you know, stopping for 6 months and, you know, kind of ethical approaches. You know, what do you think we should be doing as, do you think this is an opportunity? I'll expose my bias. I think this is an opportunity for knowledge graphs and semantics people to talk about the metrics and transparency. What do you think we should be doing to respond? What do you think the big field should be doing to respond to those requirements, like the AI Bill of Rights?
Well, I think you can't stop it because you may stop, but somebody else is going to continue and they're going to acquire it. So it's sort of ridiculous.
Yeah.
So going forwards with current and possible future issues and putting some kind of metric and guardrail is a good discussion. I don't think it has to be policy yet, but I think to understand where there's going to be trouble, I mean, it's why we do genomic research in viruses, even though we like to, you know, suggest that they leak out every once in a while, but I think you have to look at it. And I think the knowledge graph approach is coming up more and more often as the right orthogonal system that doesn't get screwed in its thinking, or whatever you want to call it, of an LLM, and might be the perfect fence for that.
Yeah, that's kind of one of the places that I'm going. And by the way, Brockman from OpenAI in his opening talk said, you know, one of the reasons we put out OpenAI was to let the world test it. Which, you know, is a position. You understand the position. You know, whether it's wise or not is another question. But, you know, do we as a field have some technology that can help?
So I'm going to rip off a little bit of where Jans and Jamie started, and, you know, talk a little bit about one of your earlier questions. And I'll come back to this about sort of the dangers and kind of the framing of that, right? So people are worried about jobs, and they're worried about, you know, Skynet, right? So those are your 2 extremes. The jobs argument, I think, kind of comes down to there will be jobs that are lost. There always are. There's going to be jobs that are gained. And we see, you know, this new job opportunity that Jans has thanks to laying around prompts. And then there's going to be those that are changed. And I think a lot of us are going to be in the middle. Our jobs are going to be changed. I mean, I'm looking at this personally as a great opportunity to populate my knowledge graph. I've said that. So I think the second one is, you know, the bigger one about Skynet. I'm only half joking about that, but we have so many popular culture memes that this just fits directly into it. And it's not, you know, it's not unwise to stop, pause, and think about this, but it's also smart to go back and go, all right, where's this coming from? How long have we had this in our popular culture, or even earlier? And, you know, this even gets back to some of Eric's points about what do we know, and how does this get more frightening about what do we know or what do we don't know? And so I think all of those things are kind of factoring in, and now we're at this point where we're just seeing, you know, the glimpse of a new horizon that we haven't really thought about. And so now, if I can take it back, and I wish I could give you a more intelligent answer about how the knowledge graph community can rescue all of this, but I think it does kind of come back to my point about, okay, this is something we do usually slowly, and usually with a fair amount of care and deliberation. And we start arguing about things like, what's a gene? I think Jamie and I were revamping that argument again. We spent a long time kind of going through and getting some sort of a consensus about what that means. So I think that's healthy. And so for us to really kind of have that broad community debate around the knowledge graphs and not really be super concerned about how fast it is, be more concerned about adoption and be more concerned about, really seeing where that comes together and helps us with healthcare, I think we're going to be better off. So.
I actually was completely against this 6-month, slowdown until I listened to Max Tegmark's podcast on Lex Friedman yesterday, and he actually points out a very valid argument. He says, Microsoft and Google are now stuck in this Morlock monster dilemma. Each of them has to be the bigger, better AI. And they're optimizing for one thing, profit, because there is a ginormous amount of money to be made from the company that wins this race. We're already seeing, Bing eat up a little bit of the Google market because they integrated OpenAI into their search system. And his point is very valid. What he says is Sam Altman and the guy from Google, whose name I forget, they want to stop. They've both publicly said, this is moving too fast. We need regulation. We need to kind of be told what not to do with these systems. And he says the 6 months, the 6 month is just so that the people who understand this field, which are not necessarily the lobbyists or the politicians, give them time to kind of think through the implications, write a paper, write a report that explains, much like we did with CRISPR, right? Where nowadays no scientist that is worthy of their name will use CRISPR to add genes to human babies, even though it's perfectly possible. So this is what he wants to achieve. 6 months to let the people who understand the field agree on what we as a community of AI researchers will not do, so that research can continue, right? But within these guardrails that ensure that humanity, even though we've created this new species of intelligence, can continue to persist, and evolve into a sustainable future. So I'm kind of now I kind of understand the reason of the 6 months. And to your question, I do agree that this is an opportunity for the knowledge, because we're the people who are not just okay with creating a schema, an ontology out of a database. We want to think carefully about what that means. So I do think we, as a community, should be part of that debate, because the one thing I think we all care deeply about is truth, right? And I do think a lot of these conversations around regulations and creating these boundaries around which we can continue to evolve the large language models are going to be around when is it okay to use these large language models to manipulate people, to create spam, to, because they already are being used for that, right? It's, not creating knowledge graph it's a fun application, but I'm scared that once being released into the internet, which it already is, right, it can start, it can activate the quantum computers that IBM has, for example. It can fake credit cards. It can start using, I'm a Mechanical Turk or Crowdflower to get people to do tasks. I mean, and we'll be completely oblivious to that. All of these things are happening, right?
Yeah, I'm really afraid that Google is going to put advertisement in the responses, right? So if I'm looking for a good power drill, if you pay Google, you'll go to the top, right? It's like, because paid advertisement is a problem. So now you can put it in the model itself. That would be really, really. But a question you should ask, do you guys want to have a model without a guardrail? Because I would like to have that.
Yeah.
There's a lot of things I cannot do because there's guardrails. If I'm analyzing agent customer calls, right? And I say, did the agent talk negatively about this product? ChatGPT refuses, right? It knows it's in there. I say, I first have to say I disagree. There is a negative statement, and then they say, oh yeah, you're right. It says a negative thing about this particular product. But there's so many things that it will not answer, right? But it's reality. It's out there on the web because they trained it not to say bad things about people.
Was that?
Huh?
Yeah. Was
Model user agreement.
There's
You sign that, and you're part of that. You're part of a group that is able to, and they know who you are. You can look at this sort of open or unconstrained version, but you have to sign
there's a New Zealand company that's creating a right-wing GPT, a left-wing GPT, and a neutral GPT. Political. So
are you using the web interface or are you using the actual API?
Both. But I did the query, why are there so many mass killings in the United States on schools, right? And I took that answer, which was what you usually would expect, say, from the Washington Post, New York Times, right? The big answer, because I'm going to test it once the right-wing GPT and the left-wing GPT are coming out to see how it deviates from this answer and the other ones. I mean,
he's running social experiments. That's with GPT. That's amazing. So oftentimes when I'm faced with kind of this disruptive change and uncertainty, I turn to like scenario planning or scenario modeling. So let's wind the clock forward 12 months. We're sitting on this same panel. How has this conversation advanced? And what did we predict and get right? And what did we predict and get wrong? I'm very curious about kind of your ability to populate knowledge graphs with GPT and the advancements that might lead to. Did that create kind of a positive force forward? I wonder what other kind of things, signposts we can imagine over the coming 3 to 6 months that would say, yeah, this is headed in a very interesting direction. Do you have any thoughts on that?
You look at me.
Actually, I've been doing experiments with knowledge extraction using not ChatGPT, but using GPT, and it's pretty good. I mean, you can get some stuff. You can get some really good triples out of it, and if you split the problem in just the right place, you can get some very good results out of it. And the question from there is, well, how do you really evaluate it effectively? Because if you want to figure out if it's doing text generation from triples, it's like, well, then you have to read everything to see if it's actually decent, and vice versa. How do you know that any data set actually has all the triples that can be said in a sentence? What's your criteria for like what is a good extraction for it? Because it's at that point now where it's like, this could be up for debate depending whether or not this is actually like really good or just okay.
So we have about 7.5 minutes left. I don't know whether there's any burning questions from the audience. Ooh, there's one. Oh, Shani.
It's a question. I really liked Jan's synthetic data generation using ChatGPT. As a person who has used Cynthia, I find ChatGPT to be much easier when it comes to generating synthetic data. But at the same time, there have been stories of software engineers putting in proprietary code into ChatGPT for checking errors, for optimizing code, for example. Now, we haven't heard anything with respect to physicians putting, patient records to, give a diagnosis or something like that. But given, this is the healthcare and life sciences and we are talking about knowledge graphs, I was wondering and you also talked about guardrails, how you didn't like guardrails, but I think this is one.
I did not like who?
Guardrails.
Oh, guardrails.
Yeah.
Guardrails, yeah.
But, I was wondering because, there's so much protected data in patient information, is if there's something we can do with knowledge graphs, maybe, hey, this is a protected attribute, so we probably shouldn't feed this into the model. And this is like, kind of a brain dead, solution I'm saying, but there could be some other more complex solutions that we can think of that uses knowledge graphs to kind of filter out or sanitize data that goes into the large language models. So I want to hear the thoughts of not just you, from the entire panel about this, how we can utilize knowledge graphs to sanitize the data that's coming into large language models, not just to populate the data, populate knowledge graphs using the data from large language models.
Well, I'm very interested in event prediction because we're making entity event knowledge graphs in various industries. We have one for aircraft, right? We have maintenance records, many different types. And for me, always the most important, but most interesting question, what is the next thing that's going to happen, right? I mean, that's the only thing interesting for us human beings, right? What's going to happen next? And I can see that we take what you just said, the patient data, right? And feed that into your own model of patient data. I think it's amazing things could happen if you did that.
Exactly. I think when you dive into how RLHF works, reinforcement learning with human feedback, it's basically just here's a prompt, GPT gives you a set of answers, and the human being picks the best one. Right now, imagine we take all of these medical records. Right, we take the medical history of the patient. We take the patient, the treatment history. That's your prompt, right? And then GPT is going to give you a set of answers, and you pick the one that matches the reality, right? So that's one way of using, reinforcement learning to actually make these models work for us. So if you grab that information into the knowledge graph, you have to separate it into what's the prompt, what's the right answer, right? And by the way, you can do the same thing with research papers, right? Every research paper has a hypothesis and then the conclusions, right? So we can actually use that to automate the knowledge creation, knowledge generation, or retraining these models so that they actually give us something that a scientist would be okay with.
So is that one of the killer use cases from the 11 learnings from our keynote this morning?
Yeah, well, I don't think we want it writing our papers for us.
Do we need to write papers? Is my next question.
Oh, well,
right? It's like all science is now being transacted into knowledge models, language models.
Yeah, I can't hypothesis on that one. Anybody?
Well, I'm going to say that the one part of science that any language model cannot do, and is probably still best done through the process of language, is asking ourselves and the rest of the world the question, what if I'm wrong? That's the foundational question of science. What if I'm wrong? You come up with a guess and then you get a result, but what if this is wrong? What if I did something wrong to get that answer? We do that over and over again until we eliminate all those possibilities. And that's a very open-ended question. And because it's so open-ended and because it's so fact-driven and knowledge-driven, it's not really something that language models can handle at this point. And it's not really something that there have been a lot of efforts around trying to represent the research process or research workflows in knowledge graphs, but the actual process of thinking it through is not something that will happen except linguistically until we can figure out how to, what's that? Is there a magic thing that we're doing that can be distilled to 5 predicates? But probably not.
Okay, so 3 minutes left. If somebody on the panel wanted to give some advice to the knowledge graph community on places to focus, is it what Jamie just said? Is it something else? Who wants to speak up?
I would recommend play as much as you can, because we're just all beginning to learn, right? We're all scratching the surface. And I mean, I did that work with the wine ontology only to learn about how to do it, right?
I love it.
And I did it to I made so many mistakes, but you learn so much along the way when you do it. So just play.
Yeah.
That's it. The only thing.
Same thing. Just try out prompt engineering. That's it's a whole thing, and it's not just about jailbreaking the models. It's about actually figuring out how to get it to do useful work using content that you provide it, and it is surprisingly effective.
Yeah, I think experimenting with use cases and try to see where you can start to get adoption. I think breaking down the personas and how understanding how humans are going to interact with this technology is a really curious thing for me as well. And I think some of the work that was presented earlier, how do we put these tools in the hands of these different personas who can then take advantage of them?
So I want to pick up on a conversation that Lena and I must have had about a month ago. And it was, the effectiveness of ChatGPT is based on it basically swallowing the internet and then having schema.org use that to structure it. And I think one of the things that we're concerned about is what is that going to look like for life science, because there's going to be so many places where it's just not well covered at all. It's just not on the web. It's either in people's heads or it's, buried in, box folders somewhere at, Pharma XYZ. And so, especially for things, that just it came up over lunch, things like the negative results, which you really want to have in there. So there was a proposal potentially to build one together as a community as part of a Pistoia project. And so is that something that seems like a good idea? Does that make sense to the community? Something we might want to come out of just recommending, do we build a large language model that's more focused in the life science space, do this as a pre-competitive thing, and see if we can get some funding for it?
I'll build on that idea and kind of bring back the post you sent me yesterday. So yesterday, Tom was doing homework for this panel, and
on the train,
he sent me a snapshot. He asked GPT, "So what are the implications? How can we use knowledge graphs to improve large language models?" And he came up with like a series of interesting things to do with knowledge graphs. So my proposal is let's talk about it as a community. Let's see what we can do about creating part of that white paper that we can then use to create those guardrails, and doing it through the Pistoia and kind of actually start to implement this biopharma GPT that we can all trust and use and improve as we go. Just like Wikipedia, right? Nobody trusted Wikipedia at the beginning. People were like, "What do you mean you're taking internet you're taking knowledge from the internet?" But nowadays it's been proven it's more accurate than Encyclopedia Britannica. So, Wikipedia won. Just like I think if we build this biopharma GPT model, we may be able to give ourselves a real accelerator.
So has anyone played with Dolly?
Mm-hmm.
I have Dolly. The Databricks has their own, because every enterprise I talk to is worried about one thing, and that is if I train it on my data and I give it my data, then it's going to leak. There's the Samsung case, right, where the internal document leaked out. So everyone wants to have their own on-prem
ring fence.
Around it, and so we've done some training on our own documents, but then you always get the mix of what they did and then what you added, right? You still can't trust the answers. So, but the answer is that's why it's going to be a little bit slower, because big enterprises will be afraid to give. I wouldn't give all your AstraZeneca data to ChatGPT yet.
Only if I really wanted to leave the company quickly.
Well, Samsung is outlawed because of that.
Yeah.
But I mean,
what is the path then? What is the path to try to get that hybrid model? And I know folks are trying to figure that out. That's a very active area of development.
I think one place that we really have to look is semantic search engines enhanced with ChatGPT, where you make a knowledge graph with your documents, split up in chapters, maybe even paragraphs, right? You have your regular taxonomies to get all the elements, all the entities, right, that you have out of the text. You do your regular semantic search, and then you ask ChatGPT to think about it, to read it, to give an answer, to summarize it, to find causal connections in there. It's that's one way where you can do it now if you can't build yet your own, because it took $100 million, right, to build a GPT-2.
All right. Well, so maybe that's one of the charges: semantic search to enhance LLMs, and maybe LLMs to
enhance the search. Yeah.
And with that, we're essentially out of time. And thank you to the tech people, because they didn't know that we were going till 6 o'clock, so they graciously stayed. So thanks very much. Follow-up questions are most welcome. Thank you to the panelists. And I'm on board for this, Yeah, but actually the negative results too.
Yeah,